Dr. Sharad Chandra awarded with PhD degree from Geetham University, Visakhapatnam. He has an experience of 17 years in teaching. He is currently working as an associate professor in ECE and in charge academics and planning, Department of ECE, Mathrusri Engineering College. He has published 14 papers in Scopus and Web of Science journals. He also published 2 patents. He is a senior member of IEEE and life member of technical chapters like IETE, ISTE. He is currently the treasurer of IEEE Signal Processing Society, Hyderabad section. He has presently the executive council member of IETE Hyderabad section, Usmania University, Hyderabad. He is also the executive council member of the Telangana State Committee of ISTE chapter for the period 2021 to 2024. He was awarded with Outstanding Educator Award for the year 2019 from International Institute of Organized Research during 4th International Convention on IRSD 2020. Please welcome, sir.
First of all, myself, I am Dr. Sharad. I am currently associated with Mathrusri Engineering College. I work as an associate professor and in charge for academic and planning there. I am also a part of, as stated in my profile, I am also a part of different kinds of communities, professional communities like IEEE, IETE and ISTE. And I'm very happy to be a part of this AECD 3-day workshop on this quantum related technologies. Hope you are all equipped with some of the basics related to this quantum computing. I hope so. For the last one day, you might be experiencing around 4 to 5 lectures where you might have at least got some basics. Okay, anyways, I'm sorry. Actually, this is Aicte Vani Program, and I was asked to speak in Telugu. Okay, thank you. Anyways, the better the communicators. What do you actually gather? Okay, so let us not. I try to break the monotony. Okay, what was happened for the last 4 or 5 lectures. I would like to just break the monotony. మనం ఏం చేద్దామంటే కొద్దిగా ఇంటరాక్ట్ అవుతాం బికాస్ ఐ డోంట్ థింక్ ఐ వాజ్ ఆస్క్డ్ టు స్పీక్ ఆన్ quantum programming and simulation. Simulators actually. It was printed as simulations, but it was simulators. I was asked to talk on this particular topic, and I bet no one could actually get at least delta of this particular quantum programming within this 1 hour. Okay, మనం ఏమీ నేర్చుకోలేదు నిజంగా చెప్పాలి అని అంటే we can't actually learn anything in this 1 hour. But anyways, those who are very much interested in quantum programming and simulation, as a programmer, you might be experiencing different kinds of programming languages. మీరు ఇప్పటివరకు చాలా వరకు చదువుతారు. At least C, Python. Okay, at least C చదువుతారు కదా. C, MATLAB మీద వర్క్ చేస్తుంటారు. I guess you are all students of EC. Yeah, thanks. Okay. That means you might have got some exposure towards MATLAB. Okay, something related to you might have also seen multi-sim or any simulation, very long related software. Okay, today I would like to నేను ఏం మాట్లాడదలుచుకున్నానంటే అసలు క్వాంటమ్ కంప్యూటింగ్ కి నార్మల్ క్లాసికల్ కంప్యూటింగ్ ఉన్న డిఫరెన్స్ ఏంటి, క్వాంటమ్ ప్రోగ్రామింగ్ కి క్లాసికల్ ప్రోగ్రామింగ్ మనం చేసే నార్మల్ ప్రోగ్రామ్ కి ఉన్న డిఫరెన్స్ ఏంటి, క్వాంటమ్ ప్రోగ్రామ్ నేర్చుకోవాలి అని అంటే ఏం చేయాలి, ప్రోగ్రామింగ్ చేయాలి అని అంటే ఏం చేయాలి, క్వాంటమ్ ప్రోగ్రామింగ్ లాంగ్వేజెస్ ఏమేమి ఉన్నాయి. ఓకే, ఏమేమి కంపెనీస్, ఇట్స్ నాట్ అబౌట్ ప్రోగ్రామింగ్. ఓకే, ఇట్స్ నాట్ అబౌట్ ప్రోగ్రామింగ్ ఆల్వేస్. మీరు చూస్తుంటే MATLAB, it is something like a toolkit. Okay, there are many kinds of tool boxes which are available. They are bundled together. కదా, మీరు ఆటోమొబైల్ ఇంజనీరింగ్ కి సంబంధించి చేస్తారు, mechanical engineering or electrical, any kind of simulations you will be able to do that using the same software. కదా, అలానే మనం కూడా క్వాంటమ్ ప్రోగ్రామింగ్ చేయాలి అని అంటే ఓకే మనం కూడా it is not only important that you know the programming language, you also need to have how to handle a SDK. Okay, SDK and DDK. So we'll try to introduce. Okay, we'll try to let us get exposed to some of those basic terminology related to quantum programming. Okay, that's what my idea is. I'll speak for another 30 to 45 minutes here. Okay, I try to give you some knowledge. Okay, మీరు ఎలా స్టార్ట్ చేయాలి, ఎలా నేర్చుకోవాలి అని అంటే కదా, క్వాంటమ్ ప్రోగ్రామింగ్ కనుక నేర్చుకోవాలి అని అంటే మీరు ఏం స్టార్ట్ చేయాలి, ఎక్కడి నుంచి స్టార్ట్ చేయాలి, ఎందుకు క్వాంటమ్ ప్రోగ్రామింగ్ ఈ రోజుల్లో you might have seen in our neighboring state AP, they have come up with Quantum Valley, and everybody was talking about new age computing, that is quantum computing. All the companies, whatever you name, okay, all the big techie companies, they are after quantum computing. They are trying to prepare their own quantum computers. Okay, quantum systems is trying to try. Why they are in this big race? ఎందుకు ఈ రేస్ లో ప్రతి కంపెనీ ఇంట్రెస్టెడ్ గా, అండ్ మోస్ట్ ఇంపార్టెంట్లీ IBM is a global leader of this quantum computing technology. They have come up with different kinds of technologies, different kinds of languages, different kinds of toolboxes, toolkits, which actually supports each and every individual like it. Okay, IBM చేసిన స్ట్రాటజీ ఏంటి అంటే they haven't come up with a commercial package. వాళ్ళ స్ట్రాటజీ ఏంటి అంటే they have given freebies to the academics లో ఇలా మనలాంటి వాళ్ళకి ఫ్రీగా క్వాంటమ్ కంప్యూటింగ్ నుంచి నేర్చుకునేటట్టు వాళ్ళ టూల్ బాక్స్ ద్వారా నేర్చుకునేటట్టు they are coming into the market. Their idea is something like that. Everybody అంటే మన క్వాంటమ్ కంప్యూటింగ్ అంటే IBM కిస్కిట్ తప్పితే వేరే లాంగ్వేజ్ తెలియకుండా చేస్తారు, వేరే టూల్ బాక్స్ వేరే పర్టికులర్ SDK తెలియకుండా చేస్తారు. There are many things, చాలా ఉన్నాయి, కానీ IBM ఏం చేస్తారు అంటే they are coming up with their own an SDK such that everybody at the academic level only, you will be experiencing that particular SDK. అంటే మీకు క్వాంటమ్ కంప్యూటింగ్ అంటే మనం దేంట్లో చేయాలి అని అంటే టూల్ ఏంటి అని అంటే డిస్క్రిట్, దిస్ ఇస్ ద ఓన్లీ అవైలబుల్ టూల్ అని అనిపించేటట్టు అకాడమిక్స్ లోకి తీసుకొస్తారు. ఓకే, ఆల్ ఎడ్యుకేషనల్ ఇన్స్టిట్యూషన్స్ దే ఆర్ గివింగ్ ఇట్ ఫర్ ఫ్రీ. Okay, we'll try to talk this a little later, but however, I'll start with some of those basics here. What is quantum programming? How this is different from classical programming? Okay, classical programming, you might have seen microprocessors. Mana computers evaithe microprocessor nadustunayo. Classical operations such as manam enta save chestunna gani we see practical applications like most importantly mathematical operations చూస్తున్నాం, or else some engineering applications which actually engineering applications అంటే we try to bring out some kind of mathematics or physics or chemistry into this particular application and try to bring some kind of technology we develop through these engineering methods. Okay, మన సాఫ్ట్వేర్స్ ఇప్పుడు వరకు మీరు చూసిన C అని లేకపోతే C++, C# or somewhere around Python nowadays, they are all having a good. Okay. I would like to sum up these things in a different way. మీరు ఏమనుకుంటారు అసలు క్లాసికల్ ప్రోగ్రామింగ్ ఏంటి అసలు? వాట్ we are మనం మీ థాట్ చేయండి, ప్రోగ్రామింగ్ అంటే మీ థాట్ చేయండి. And what my point is, quantum programming is no different. It is no different from classical programming, but what's the main difference is, if you consider a quantum system, okay, your quantum related programming can't be done on normal classical systems that what you have. Your PCs or your processors might not support our quantum computing related technologies. Okay, ఈ క్వాంటమ్ సిస్టమ్స్ ని ఎనేబుల్ చేస్తూ మనము ప్రోగ్రామింగ్ చేయాలి అని అంటే ఆ పర్టిక్యులర్ నేచర్. ఓకే, we can't build. Sometimes what happens is you can't actually build a quantum computer. మీ own quantum computer మీరు చేసుకోలేరు కదా. Okay, and it is very costly nowadays because we are in a premature stage and therefore these quantum systems are very costly. This quantum programming or quantum simulators help us to create a separate environment such that ఈ క్వాంటమ్ రిలేటెడ్ టెక్నాలజీస్, క్వాంటమ్ రిలేటెడ్ సాఫ్ట్వేర్స్ ని మన ఓన్ క్లాసికల్ కంప్యూటర్స్ మీద వర్క్ చేసుకోవడానికి ఒక పర్టికులర్ ఎన్విరాన్మెంట్ ని క్రియేట్ చేస్తుంది. ఓకే, ఆ పర్టికులర్ ఎన్విరాన్మెంట్ ద్వారా మనం ఏమైతే ప్రోగ్రామింగ్ చేస్తామో క్వాంటమ్ రిలేటెడ్ టెక్నాలజీస్ కోసం దాన్ని క్వాంటమ్ ప్రోగ్రామింగ్ అంటారు. అండ్ ఇట్ ఈస్ nothing different from what you have learned as C, C#. These are languages. Okay, it is a way to communicate with the system. Okay, to understand. Okay, మనం ఏమైతే చెప్తున్నామో అది అండర్స్టాండ్ చేసుకోవడానికి ఒక లాంగ్వేజ్. సిమిలర్లీ ఈ క్వాంటమ్ ప్రోగ్రామింగ్ లాంగ్వేజెస్ కూడా చాలా వేరీడ్ గా ఉన్నాయి. ఇట్ ఈస్ నాట్ దట్ ఇట్ ఈస్ ఓన్లీ త్రూ C or through Python or through some another languages. Okay, nowadays Java is also, IBM is also working on more like C#, that is .NET, as well as Java also. But most of the students like you, most of the engineers, those who are coming out, they are very well versed with this Python language. Okay, చాలా మందికి ఇప్పుడు Python చాలా ఈజీ అయిపోయింది. అంటే లాంగ్వేజ్ ఇట్ ఈస్ ఆల్మోస్ట్ లైక్ నార్మల్ లాంగ్వేజ్ దట్ వాట్ వి స్పీక్. మీరు MATLAB చూసుంటారు కదా, మీ అందరికీ MATLAB you might have dealt with MATLAB. Okay, have you programmed have you written your own programs in MATLAB other than what is there in your manual? Try it. It is very easy. You doesn't require a guide. Okay, మీకు ఒక టీచర్ గానీ ఒక ప్రొఫెసర్ గానీ ఎవరి హెల్ప్ అవసరం లేదు. MATLAB itself offers enormous help, and all the functions or the keywords that we use in MATLAB, okay, they are very normal. అంటే మనం ఏదైతే మాట్లాడుకుంటామో ఆ పర్టికులర్ ఫంక్షన్స్ దానికి ఆ ఫంక్షన్ నేమ్ పెట్టేస్తాం. ఓకే, it is previously it was open-ended. That means you as a developer, you as a programmer, you can also add your own functions to the MATLAB libraries. Nowadays ఇప్పుడు కూడా చేసుకున్నాము. But however now ఇప్పుడు చేసే స్కోప్ లేకుండా over the past 15 years MATLAB function libraries has been grown into millions. అన్ని ఫంక్షన్స్ ఉన్నాయి. ఎందుకు నేను అలా చెప్తున్నానంటే ఇప్పుడు why I am Python language is what అంటే మీరు MATLAB బాగా చూసారు కాబట్టి MATLAB లో డాట్ ప్రోగ్రామింగ్ మనకి బాగా చేశారు కాబట్టి Python నేర్చుకోవడం అసలు కష్టమే కాదు. Okay, it is almost similar to what you do in MATLAB. Okay, therefore once you know about MATLAB తెలిస్తే కనుక MATLAB languages మీకు కనుక ఈజీగా తెలిస్తే most of the functions are common to your Python languages also. Therefore, it will be very easy for you. And all the ఇందాక నేను చెప్పాను కదా బిగ్ బేస్ లో చాలా కంపెనీస్ ఉన్నాయని. Most of the companies they are bringing their SDKs based upon Python language. Okay, as a developer or as a programmer, you doesn't have any kind of future లేదు. నిజంగా చెప్పాలి అంటే you doesn't have any future for writing a program for a particular application. అప్లికేషన్ కి ప్రోగ్రామింగ్ చేయడానికి ఈ రోజుల్లో మీకు అసలు ఎవరికి డెవలపర్ అవుదామని అనుకున్న వాళ్ళు కూడా ఫ్యూచర్ లేదు. బికాస్ విత్ ద అడ్వెంట్ ఆఫ్ చాట్ జీపీటీస్ అండ్ ఆల్ AI రిలేటెడ్ సాఫ్ట్వేర్ యు ఆస్క్ ఎనీథింగ్. ఓకే, యు ఆస్క్ ప్రీవియస్లీ కొద్దిగా ప్రీమెచ్యూర్డ్ లో ఉండేది. ఏంటి మీరు జస్ట్ అప్లికేషన్ అడిగితే అప్లికేషన్ రాసేది, బగ్స్ కూడా చెప్పేది కాదు, ఏమేమి బగ్స్ ఉన్నాయి అలాంటివి కూడా చెప్పేది కాదు. నౌడేస్ ఎవ్రీ డెవలపర్ that's why we are seeing the big crunch in the job market. Okay, only because AI has almost wiped out the developer position in the technical fields, creating any application within seconds. It's not about hours or days also. Okay, మీ ఓన్ ప్రోగ్రామ్ మీరు రోజులు రాసేది సెకండ్స్ లో రాస్తారు. కాబట్టి అప్లికేషన్ డెవలపింగ్ అనేది అసలు ఈ రోజుల్లో అసలు మాట్లాడలేదు. ఇప్పుడు ప్రోగ్రామింగ్ మనం ఎక్కడ చేయాలి అంటే ఇలాంటి AI సిస్టమ్స్ ని బిల్డ్ చేయడానికి మనం ప్రోగ్రామింగ్ చేయాలి. Or else our AI systems లో ఉన్న bugs ని remove చేయడానికి we need to program. And these quantum computers or the quantum systems, they actually handle very big data. Okay. I would like to speak about some of the basics related to classical computers, classical systems lo generally your own systems. I would like to say what is happening in what is happening in a classical computer versus in a quantum computer. I thought of showing with a diagram, but however, anyways, classical computer normally data handle chestam. How do we handle the data? Or else computer ela handle chestam? You know, everything is in bits, which is in zeros and ones. Why only zeros and ones? Why only computer understands zeros and ones? Why not from any other position? Why not some other voltage? Generally zeros and ones are computer zeros and ones. Electronic engineering మీరేం చెప్తారు? జీరో అండ్ వన్ మీరు ఎలా చూస్తారు? సింపుల్, లో వోల్టేజ్ హై వోల్టేజ్ అంతే కదా. Why it is only handling low voltages and high voltages? Why not medium voltages? Why doesn't it have a brain to understand the middle voltages or the medium voltages? Why it is not able to decide? Why always it is going to have only the zeros or ones? What is happening there? This is the idea which actually revoked this quantum computer systems. Okay, how to handle a large data? Why only with respect to only two values? Why can't we handle multiple values? Okay, here also we do have the same thing. కానీ మనం ఏదైతే లెవెల్స్ పెట్టుకున్నాం, మనం ఏంటి ఇప్పుడు something like high voltage or low voltage based upon some threshold, we try to either round off to either 0 or 1. Okay, we are always doing that. Okay, then how to handle there is something which is exactly in the middle. How the computer tries to understand whether it is 1 or 0. Do you really have a thought on this? అసలు ఎప్పుడైనా మనం ఆలోచించాము గురించి? That might be in most of the cases in classical computer. What happens is 75% of the times it takes you either 1, 25% of the times it takes 0. Here, based upon this, there might be some kind of information losses. Okay, there might be. Okay, I don't say that always there is an information loss, but there might be some information loss. Then how idea in mind. Generally, the quantum computing systems evolve. Then what has happened in quantum computers or quantum systems? Quantum computing systems ela handle this. So now, any particular thing that what we generally say as a voltage here, quantum mechanics might have heard about a photon. Okay, photon is a energy driven particle. Okay, it might be placed in a three-dimensional space, just like your x, y, z axis. Okay, you might have seen x, y, z axis. Ninna మన lectures లో మీకు ఏమైనా కొన్ని diagrams చూపించుంటారు. Okay, how do we define a qubit and all? Qubit ని మనం జనరల్ గా 1 or 0 కి ఎలా చెప్తున్నాము? Okay, మీకు చూపించుంటారు. Okay, a diagram లో you might have observed that if at all if it is located either in the middle of this particular position, then how we are actually trying to say about it? Okay, how we are trying to differentiate it from one part, then magnitude same ఉండొచ్చు. How we are actually trying to say with respect to phase. Okay, ఈ superposition diagrams లో మనం ఎలా చెప్తున్నాం? Okay, how do we represent it? With the same 0 or 1 state qubits లో, it might have different phases with different kinds of it actually creates that kind of differentiation. Okay, anyways, I hope that you have the basis. I would like to just say now some of those basic things. Whenever you say the quantum program, it is just the development of algorithms or software that harness the power of quantum computer. Okay, you might not have a quantum computer with you. Just this quantum programming software might help you to create a virtual quantum computer. And similarly, it might help you to actually create some kind of quantum circuits, applying quantum gates, implementing basic quantum algorithms like Shor's algorithm for finding large numbers or Grover's or such algorithm. These are some kind of data structure based algorithms. You might have actually dealt with this. Now these kind of algorithms, okay, in order to handle all these things, there is a separate environment which we are trying to create, and that has to be created through this quantum program. Okay, and now what are the core concepts that you need to understand whenever you are trying to deal with quantum programming, basically? I guess you have already heard about these things. Qubits in superposition. ఇప్పటివరకు మీరు ఈ 4 hours లో at least you might have dealt with this. What is a qubit? It is a basic unit of quantum information that you might have seen. Generally, మనం ఎలా అయితే చెప్తున్నామో classical computing లో మనం zeros or ones ఎలా అయితే చెప్తున్నామో, similarly qubits are the ones which are the basic things which is understood by a quantum computer. Okay, what is the superposition principle? How does it help us here? Superposition ఏం చేస్తాం అంటే superposition ని ఇక్కడ ఎలా చూస్తాం? qubit superposition లో ఉంది అని ఎలా చెప్తున్నారు? So because understanding these concepts is really important to actually write a quantum related software. ఏదైనా ఒక సాఫ్ట్వేర్ లో ప్రోగ్రామ్ రాయాలి అంటే ఇవన్నీ అందరికంటే చాలా ఇంపార్టెంట్. ఈ టర్మ్స్ at least, okay, I don't want to say once again, I don't want to repeat all these things. You might have heard about this, but please try to understand. Okay, whenever you start as a programmer, a quantum programmer, the first 5 things that you need to better understand are qubits, what is qubits, and how this superposition or entanglement generally help us. What is a phenomenon? Okay, entanglement and a property ela help chestadi qubits to 2 or more qubits ni handle cheyadaniki. Okay, you need to just understand that how that correlation actually works between any 2 particular qubits. Here we are not actually dealing with a single 0 bit or 1 bit. Previously what we have done in classical computer, you might handle bundles of qubits together. Okay, and entanglement processing, this has to be clearly understood. And what is measurement? Measurement and data. Okay, you need to just understand this stuff. Okay, I don't want to say what is quantum. I need to start somewhere around quantum mechanics, which is start basically one is above. But I don't want to say that. But you as a learner, as a beginner, try to understand the basic difference between all these particular concepts. Clearly, అర్థమైతేనే మనం quantum programming చేయగలుగుతాం. Okay, and the next one is measurement and collapse. It is what is measurement actually? And it is something like you need to observe the objects and understand what your qubit is actually conveying us. The zeros and ones bundles ఉంటాయి కదా, వాటి నుంచి మీకు ఏమైతే వస్తుందో, ఏ ఇన్ఫర్మేషన్ అయితే వస్తుందో దాన్ని మనం మెజర్మెంట్ అంటాం. వాట్ ఈస్ కొలాప్స్ యాక్చువల్లీ? హౌ డు యూ సే దట్ ఇట్ ఈస్ కొలాప్స్డ్ ఆర్ సంథింగ్ లైక్ దట్? సమ్టైమ్స్ ఈ బండల్స్ నుంచి మనం ఏదైతే ఫైనల్ రిజల్ట్స్ ని మనం గ్యాదర్ చేస్తామో, once we have the final results with us, then we say that that particular qubit information is collapsed. Final results మనం గ్యాదర్ చేసుకుంటాం. This is, అంటే నేను చాలా సింపుల్ గా చెప్తున్నాను, but it is not that simple to understand actually, but this is the general way to understand it. And you know about different kinds of quantum gates, analogous to AND gate or inverters or NAND or universal gates in your classical computing. Here we do have some special gates. These came from the reversible logic. I hope that okay, I guess that you doesn't know about this reversible logic. But however, all the gates such as Hadamard gates, Pauli gates, Toffoli gates, okay, C-Not gate, okay, these are some of those basic gates that what we need to understand here. Quantum gates ela work chestayi. Quantum gates generally works on reversible logic. Reversible logic in the sense, previously in the case of normal classical gates, you might have seen that with two inputs you might have actually having single output, or with multiple inputs you might have single output, or with single input sometimes you might have also experienced some multiple output. This might not happen generally, but this is a common case. But in reversible logic, what happens is, generally if you have two inputs, there might be some two outputs as well. Okay, and these two outputs might whenever you try to reverse the logic, you will be able to get back your original inputs. Okay, and that happens in all these particular gates that what we generally see in quantum technology. Okay, their approach is through reversible logic. And similarly, all the circuits that are built through this particular gates, generally we call them as quantum circuits. Okay, most importantly, the C-Not gate, what we call it as combined NOT gate. It is a basic gate, just like our inverter. And similarly, we do have our Pauli's gate, Toffoli, Hadamard. Okay, and these are some of the basic gates that what you need to understand. Okay, and once you have this, and then you try to understand about this interference and phase. How these help us to differentiate the information expressed in the same qubits. Sometimes you might represent the same information, same kind of qubits. Okay, qubits ni meeru Dirac notation to notate cheyadam avanni chusuntaru memory nunchi, or else normal ga manaku ardham kaavadaniki avey vaatini manam normal decimal laga raskodamu ivanni chusuntaru. Okay, similarly, if at all if a particular bit's position generally might represent with the same value, okay, then how to actually differentiate the quantum information? Generally we do that through phase of that particular qubit setup. Therefore it is very much important to understand what is actually happening. Okay, ee 5 things ardham kaakunda manam quantum programming ni start cheyalli. Okay, and this is the primary thing that you need to understand, and skills and prerequisites. Once you understand these things, it's not that previously we might have seen some kind of programming where we might have actually dedicated to a particular subject. You know, mathematics ki sambandhinchi edaina oka software use chestunte generally we write only programs related to mathematics. Okay, and somewhere around signals and systems chadivaru basic simulation labs chesaru. Okay, and electronic circuits chesaru, daniki sambandhinchina simulation software. We have dedicated software. But however, all this discrete related technology, not only this, but any quantum related software or SDKs, you need to at least have the knowledge on all these particular things. Okay, it is the three things. First one is the linear algebra, where you need to actually try to understand about the complex vector spaces. Okay, vector algebra is also a part of algebra. Okay. Some classical matrix operations you need to understand matrix operations. Sometimes we say about representing differential equations through uh, complementary equations. Complementary equations and particular solutions you might have solved for a LC normal differential equation. చదువుంటారు కదా మ్యాథ్స్ లో ఒక హోమోజీనియస్ డిఫరెన్షియల్ ఈక్వేషన్ సాల్వ్ చేయాలి అని అంటే యూ కాంప్లిమెంటరీ ఫంక్షన్ పర్టికులర్ సొల్యూషన్ అండ్ వాట్ ఆర్ ఐగన్ వాల్యూస్ are nothing but the roots of this complementary. Okay, you need to have a clear understanding of how to calculate this, represent the eigen values calculations. How are you allowed there? Okay, eigen, what might actually say. Okay, this is almost like your undergrad level math. Okay, you need to have all the core concepts that what you might have studied in your undergrad. Okay, that is very much important. And most importantly, you need to understand the bracket notation. That is what we call as Dirac notation. Okay, the bracket notation is also important. That is and because bracket notation is a compact way of representing a vector. Okay, quantum qubit is almost like a vector. Okay, it has both magnitude as well as phase. Once you understand how to be represented through Dirac notations, then only you will be able to understand what is the information carried by that qubit. Okay, without understanding that we can't do that. And next one is the probability and statistics. Since most of the times we deal with okay, there is a lot of uncertainty dealt with qubits. Okay, the information carried by your qubits or the energy levels that are carried by your qubits, they have different types of uncertainty. Uncertainty is also an uncertainty. Undoubtedly, you need to know the branch of uncertainty that is. Okay, therefore, probability and statistics. This is, we are not exclusively exposed to the statistical related parameters related to handling different types of probabilistic data. We do have in computer science probability and statistics any particular subject of it. That subject might help you to actually understand some of them. One random variable, random process concept to list. But that is something else in order to help us in our digital communications and all. But you need to understand some of those other related statistical data also. Okay, samples coverages, and similarly basics, at least basic statistics. Okay, in order to handle the large volumes of data. Okay, and next, most importantly, we need to also have basics of quantum mechanics. Okay, you need not dive deep into this quantum related mechanics and all, but you need to still have what are basic principles of quantum mechanics. It is very helpful whenever you would like to be a programmer. Okay, and quantum mechanics principles say VANI. The fundamental properties and superposition, entanglement, whatever you say, wave functions, everything, every uncertainty principle, Heisenberg's uncertainty principle, everything they come from quantum mechanics. Okay, once you understand these principles quite clearly, then it might help us to understand and write some programs related to quantum. Okay, and these are three technical related terms or technical related fields where you need to be at least acquainted with. Okay, once you know about these things basically, I don't say that you need to be an expert, you need to know some of those basics related to it. And next, ultimately, in order to be a programmer, you need to have basic programming skills. That is what I have listed there. And then algorithmic thinking, how to approach to your problem. Okay, problem at hand, how to solve it. Okay, so therefore, try to cultivate the habit of writing your own program rather than following your manuals. MATLAB is very easy. Okay, you try different things, try to have your own program, result oriented programming. That might help you in writing this quantum program. Okay, I thought of talking about more about this qubits, traditional programming, classical programming, quantum programs, and block sphere which started yesterday. I guess you might have shown that block sphere and all. Dirac functions Dirac functions multiplication at the ఒకటే ఇన్ఫర్మేషన్ క్యారీ చేసే Dirac function ఎలా differentiate చేయాలి. I thought of actually trying to talk about these things, but anyways, I thought, okay, anyways, what are the programming languages that are being used You might actually know about C, C++. You might have heard about this. They have been used for almost at least 4 to 5 decades from now. Okay, 3 to 4 decades. This is when C language is used. Okay, 90s, almost from 90s. Okay, and generally performance optimization in real-time systems it might happen with C and C++. But what problem is you need to actually have a deeper understanding of how to handle the memory. And that means variable placing ఎలా చేస్తాం, variable calling ఎలా చేస్తాం. ఓకే, మనం ఎక్కడైతే ప్లే చేస్తున్నామో మన డేటాని ఆ మెమరీ మేనేజ్మెంట్ క్లియర్ గా తెలిసి ఉండాలి. ఓకే, హ్యాండ్లింగ్ పాయింటర్స్, హ్యాండ్లింగ్ డిఫరెంట్ కైండ్స్ ఆఫ్ అరేస్, లింక్డ్ లిస్ట్, ఎవ్రీథింగ్ ఇన్ C. Okay, generally you need to have a deeper understanding of memory management, and that can be more complex actually. That's the reason C is not a proper choice among the programs. C previously it was a good choice, but nowadays it is not a proper choice. And Julia is one of those emerging programming languages actually. It also has a relatively new program, high performance numerical and scientific computing, but here it combines both speeds of C as well as it can handle the complex differential equations what generally we try to represent through. Okay, మనం అన్ని కూడా classical systems, engineering systems మనం ఏం represent చేస్తాం, mechanical, automobile, whatever you say, electrical, electronic systems, generally we try to represent them through differential equations. Okay, the continuous time systems that what you might have studied in your analog circuits or control systems or digital signal processing, everything we generally try to represent. Any system representation is generally done through differential equations only. Okay, because we try to handle them through differentiations or integrations, which might actually represent the basic components like resistors, capacitors, or inductors through their voltages or currents. Therefore, we generally try to solve on engineering principles వచ్చేసరికి differential equation solving అనేది major part. C speed to differential equation solving చేయగలిగే ఒక particular language Julia. Julia is not that famous as of now, but it is almost like very much replaced in industries with C. Okay, but however this is not that used. Okay, and anyways Rust, it is also becoming another popular language which actually have its memory state, as we were trying to say about C lo ఏదైతే problems ఉన్నాయో ఆ problems ని solve చేయడానికి generally have for this concurrent programming. At any particular time you can handle different kinds of programs at a time. These compilers are that stable. Okay, it can handle multiple. It's not multiple until you over 10 or 100 or so, but it is something like thousands or sometimes millions. Okay, millions of programs are handled within seconds. Okay, this is done through this kind of compilers. Okay, and it's an excellent choice for performance intensive applications because it can handle more and more data, but with high reliability. But it shows it is still evolving. Okay, this is one of those particular programming language that you need to know. And all these advantages, ఇప్పుడు మనం మాట్లాడుతున్న C కానీ జూలియా కానీ రస్ట్ కానీ వాటిలో ఎన్ని అడ్వాంటేజెస్ ఉన్నాయి. Python is a primary language that is being used in the industry nowadays only because many of young people like you, they all know about Python and the ease of programming that it offers, that makes Python user friendly, and that's the reason many of the companies are also looking to write their quantum related software only through Python. Okay, and that is why it's simplicity and reliability most of the time, and with the rich ecosystem of libraries that NumPy for numerical computations, NumPy for scientific algorithms, as well as Matplotlib, just like data visualization, what your MATLAB does. Python offers a comprehensive tool, okay, when compared to all the other languages. This has a very okay, in the C, Rust, they are only for scientific computing మాత్రమే యూజ్ అవుతుంది. ఇక్కడ ప్లాటింగ్, data visualization కి data handling కూడా చాలా better. That makes your Python a very good programming languages that is being used in many of those quantum SDKs. Okay, and next, what are the key principles of programming? Okay, what do you understand? I have listed out many. Actually, I thought that this should be a one for you. Okay, నేను మిమ్మల్ని అడిగి అక్కడ డిస్ చేద్దాం బట్ ఐ డోంట్ వాంట్ టు వేస్ట్ టైం. వాట్ డు యు థింక్ ఈ కైండ్ ఆఫ్ ప్రోగ్రామింగ్ రిలేటెడ్ ప్రిన్సిపల్స్ ప్రతి లాంగ్వేజ్ లో ఉన్నాయి లేదా? కెన్ యూ జస్ట్ హ్యాండిల్ కొన్ని పర్టికులర్ కీవర్డ్స్ తీసుకొని దాంట్లో నుంచి మీరు పర్టికులర్ గా చూసిన ఇప్పుడు సి కానీ సి ప్లస్ ప్లస్ కానీ జావా కానీ పైథాన్ కానీ ఓకే మైట్ హావ్ హ్యాండిల్ పైథాన్ కొంతమంది ఎవరైనా ఓకే ఎనీవేస్ హ్యాండిల్ చేసి ఉంటాయి కదా ఈ పర్టికులర్ ప్రిన్సిపల్స్ ఏ లాంగ్వేజెస్ కి మనం యాప్ట్ గా అంటే we can match that. Can anyone say that? It's a small exercise for your mind. మీరు జనరల్ గా ఇప్పుడు జావా 4th ఇయర్ చదువుతుంటే వాళ్ళు ఈ కింద ఉన్న కొన్ని చూసి దే మైట్ సే దట్ జావా మోస్ట్ ఆఫ్ ద టైమ్ ఓకే బికాజ్ ఆఫ్ abstraction and encapsulation and all might think that these are only related to Java. Okay, but undoubtedly C or C++ is have abstraction as well as encapsulation. But most of the things that what you see here, they are all the principles of the programming. Okay, కొన్ని మాత్రమే డిస్టింగ్విష్ చేయొచ్చు, మిగతా అన్ని కూడా you try to read out clarity is through program. మీరు రాసేటప్పుడు క్లారిటీ ఉండాలి ప్రోగ్రామ్ లో. Simplicity, it should be very simple, it should not be complex. As a programmer, you need to understand. Whenever you are writing a program, you need to keep in mind all these principles. Okay? Don't try to make it complex. Okay? మనం అనుకున్న ప్రాబ్లమ్ ని ఎంత తక్కువ లైన్స్ లో ఎంత బెటర్ గా రాయగలిగితే అదే ప్రోగ్రామింగ్. ఇట్స్ నాట్ అబౌట్ రైటింగ్ ఏ 100 లైన్ కోడ్. ఓకే, అప్లికేషన్ రాయాలంటే పేజీలు రాయడం కాదు. ఓకే, హౌ బెటర్ యు ఆర్ రైటింగ్ సో దట్ ఎవ్రీబడీ కెన్ అండర్స్టాండ్. దట్ ఈస్ వై టుడే యు మైట్ హావ్ సీన్ ద GitHub. Everything is open. Okay, there is a lot of scope for different kinds of open source languages today. Every particular language which is commercially available, they have a open source language which is available in the market today. Okay, so that many open sources అంటే ఇలాంటి డెవలపర్స్ ఏదైనా ఒక పర్టికులర్ ఫంక్షన్ కి రాసి ఆ ఓపెన్ సోర్స్ టెక్స్ట్ లో యాడ్ చేస్తారు. Thereby anybody can use it. Okay, this is what happens. Okay, therefore programming చేసేటప్పుడు at least you need to have these things. Okay, without having the knowledge of these kind of principles, you shouldn't write a program. Okay, and మీరు రాసుంటే కనుక దాని ప్రోగ్రామ్ అనకూడదు. ఓకే, ఇలాంటి ఏ ప్రిన్సిపల్ కనుక కానీ దానికి యాడ్ చేయలేకపోతే కనుక ఏదైనా కదా ఎఫిషియెంట్ గా లేకపోయినా మెయింటైన్ చేయి అంటే నెక్స్ట్ మళ్ళీ దాన్ని మనం మెయింటైన్ చేయలేకపోయినా కదా ఓకే ఏ పర్టికులర్ ప్రిన్సిపల్ అయినా కనుక మనం డీవియేట్ చేస్తే అది ప్రోగ్రామే కాదు. ఓకే, whenever you write a program you need to think about all these principles. Okay, and this is one of those a programmer, it's not only a quantum programmer, every programmer has to actually try to define all these particular things. Okay, and actually as part of differentiating that what is quantum programming and classical programming, major differentiate here. Classical programming is binary logic as we were talking, and then they have some predefined deterministic steps. At the end of the day, you can actually try to guess the output. మన క్లాసికల్ ప్రోగ్రామింగ్ లో నేను చేయగలిగిన స్టెప్ ఏంటి అంటే ప్రోగ్రామ్ రాస్తున్నాము అంటే by some algorithm or by some flow chart or by some particular formula basis, you can always arrive at your result. You can cross check. Okay, you can have a predefined data with you. ఈ ప్రోగ్రామ్ చేయడం వల్ల మనకి ఏం వస్తుంది అనేది క్లియర్ గా తెలుస్తుంది. కానీ క్వాంటమ్ ప్రోగ్రామింగ్ లో ఉన్న మేజర్ డిఫరెన్స్ ఏంటి అంటే we never know what is happening. Okay, we try to program but it might end up the different kinds of results. Okay, and ఆ రిజల్ట్స్ లో మనం ఎలా చూస్ చేసుకోవాలి. Okay, that is what since this is early stages, this is very early. Okay, it is not that ఇంకా క్వాంటమ్ ప్రోగ్రామింగ్ కి ఏం చేయొచ్చు అనే స్టేజ్ లోనే ఉన్నాం. Okay, but it is not that it is too early to say these things. Okay, and then in brain matter na gani it is something like off the record because this might change itself by tomorrow. Okay, the technology is rapidly changing and it is emerging as in the quantum technology. Therefore we can't say that today this is not available. Ivala ledu ani manam ivala ittunde next second ki that might be changing. Okay, the same way here you need different kinds of ఇంతకుముందర మీరు క్లాసికల్ ప్రోగ్రామింగ్ చేయాలంటే మీరు సి .NET ఏదైనా C++ జావా ఆర్ అలాంటి లాంగ్వేజెస్ తెలిసి ఉంటే చాలు. కానీ ఈ రోజుల్లో క్వాంటమ్ ప్రోగ్రామింగ్ చేయాలి అంటే యూ నీడ్ టు హ్యావ్ అట్లీస్ట్ క్వాంటమ్ లాంగ్వేజెస్ లైక్ Qiskit. Qiskit is not actually a language. It is a Python based emulator which helps us to actually try to develop different kinds of quantum programming. Qiskit is a toolbox, as I was talking. It is a IBM developed software environment which actually helps us to do quantum programming. And similarly, it is Python based. And similarly, something like Haskell based. This is another particular language, Haskell, which Kuiper is another particular environment which helps us to do the quantum programming. Similarly, Circ is handled by Microsoft. Okay, and similarly operates on quantum programming, quantum process such as IBM Quantum and Google Cycle. Okay, all this there are quantum programming cases. You might have already experienced in the DSP process. DSP process gurinchi మీరు వింటారు కదా, third year, second, third and fourth year. Why DSP process are required? Why not your microprocessors or microcontrollers are used for DSP applications? I guess that you know the difference. Why you require a special type of a processor for a DSP application? DSP applications take to separate process cover. Only thing, మన FFTs handle చేయాలి, MAC units, multiplier and accumulators. ఎందుకు we need to have fast multipliers, fast accumulators కావాలి. Because most of the coefficients that what we see with your FIR, IIR filters, they have bundles of coefficients. But అన్నిటిని హ్యాండిల్ చేయాలంటే మనం బేసిక్ ప్రోగ్రామ్, బేసిక్ గా మనం ఆపరేషన్ చేసేది మల్టిప్లికేషన్స్, అడిషన్స్. ఇవి హ్యాండిల్ చేయాలంటే స్పెషలైజ్డ్ MAC units కావాలి. ఓకే, మల్టిప్లైర్ అండ్ అక్యుములేటర్ యూనిట్స్. ఓకే, అవి కావాలి అంటే స్పెషల్ టైప్ ఆఫ్ ప్రాసెసర్స్, నార్మల్ ప్రాసెస్ హ్యాండిల్ చేయడం DSP ప్రాసెసర్స్. Thereby you can do your FFT 1024 2048 4096 whatever you say that can handle DSP processor handle చేయగలుగుతాయి, normal microprocessor. Similarly, these kind of large chunks of data and volumes of data is not handled by any other processor. There are different types of processors developed for handling this quantum computing related data, and some of them are IBM Quantum. IBM Quantum is a processor released by IBM, and Sycamore is released by Google. And similarly, we do have different types of processors, and each particular process ki sambandhinchi VT languages ki they have specialized softwares only. Okay, IBM Quantum ni Qiskit support this. Similarly, Google Sycamore, it is using many kinds of freelancing softwares. Chala unnai. It takes, there are many kinds of levels where a particular processor understands a particular language or something like that. Okokka level lo okokka particular software ni kuda use chestam. Okay, therefore, but why మనం ఎప్పుడు చూస్తున్నా IBM గురించి మాట్లాడుతున్నాం అంటే IBM is the leader nowadays in this particular market. And now quantum programming languages ఏమేమి ఉన్నాయి? Okay, I have just listed out some. Okay, you see all the I haven't listed Amazon related web services is also available. Okay, you see the IBM Qiskit. This is the world leader, okay, in quantum computing market, and followed by Google, Circ. I thought pardon, previously I have said it as Microsoft. It has to be Google, and then Microsoft for QHash, okay, and Xanadu for Penny Lane, and Equal. This is an open source software. And similarly, OpenQ ASM. This is assembly level language, okay, and it is even high level languages. That means you can understand very easily, just like what you write it as MATLAB or normal Python based languages. But ASM is a something like last one. It is not user friendly. It is a machine level language where assembly level languages will generally use that. Okay, these are different kinds of quantum programming languages nowadays available, and most importantly, the Qiskit that what is offered by IBM is available free for you. Okay, you can handle this for free. And most of the other softwares, they are generally high-end computing kosam use chestunnaaru. High-end computing kosam use chestunnappudu problem enti ante they never use it for free. Okay, therefore we need to pay some user licenses for getting those kind of things, and we also require some kind of quantum computers to handle those things. Okay, specialized software, specialized computers kuda kavalli. And What is a quantum computing simulator? Okay, as you know, once again, quantum computing related software languages handle data. We require different kinds of quantum computing simulators, and simulators are just simulators you might have heard previously. Simulator it replicates what you actually does physically. Okay. Similarly, quantum computer or else big quantum computer మీరు ఏదైతే చేయగలుగుతారో వాటిని అన్నిటినీ రిప్లికేట్ చేస్తూ ఒక పర్టికులర్ టూల్ కిట్ ని డెవలప్ చేయగలిగితే దాన్నే మనం క్వాంటమ్ కంప్యూటింగ్ సిమ్యులేటర్స్ అంటాం. అలాంటివి చాలా ఉన్నాయి మనకి. వాటిల్లో okay, I would like to list out, but there are many classes of quantum simulators as well. Okay, something like analog, digital. We do have different kinds of simulators. We'll try to see that. Okay, first one is analog quantum simulators. Okay, using different kinds of physical systems such as simply we call them as photons. Okay, I don't want to say that as cold atoms or rapid atoms. You might not understand the notations or the jargon that what we use generally in quantum technologies. Photons, you might understand that. Okay, in order to understand, okay, you will be using directly the physical systems here. Okay, photons ne manam handle chestam ilanti kinds lo. The problem enti ante flexibility level and generally number of particles or qubits garki increase ayyite ganda ilanti kind of simulators use cheyadam chaala kashtam. That is what the problem with their analog simulators is. And analog systems lo unna challenges enti ante photons generally energy level they vary with respect to the temperature. Therefore, the environmental conditions they generally affect the this kind of simulators. Okay, analog simulators are being affected by that. And digital quantum simulators these are something different. And we see the quantum gates and algorithms generally being simulated directly in this kind of quantum systems. And they help us to implement different kinds of applications like ఎక్కువగా షార్ట్స్ అండ్ గ్రోవర్స్ algorithm ఎందుకు యూజ్ చేశారంటే I thought that Aicte Vani already చెప్పుంటారు so that I can touch upon those things. And ఇక్కడ ఉన్న ప్రాబ్లం ఏంటి అంటే entanglement in order to differentiate different kinds of qubits. Okay, అలాంటి kind of challenges still they are digital quantum simulators are facing. And another one is hybrid quantum simulators. Hybrid which has both the characteristics of both analog quantum simulators and digital quantum simulators. And they are also having great potential because they can be clubbed with the advantages of both analog and digital. But however, they are in early stages of the development. Therefore, these simulators are not in use for quantum technology implementation at all. And similarly, there are something called as tensor network simulators. These are network simulators in order to communicate between different kinds of quantum points. Okay, if there are large number of quantum computers, in order to communicate between them, generally we go for this kind of network simulators. But here also the versatility that happens with respect to analog or digital quantum simulators, it doesn't have any kind of versatility. They are less useful once again. Okay, but however, these are generally quantum simulators are segregated based upon their characteristics. Okay, how they come into use. Okay, analog, digital, we generally say with this kind of tensor flow, hybrid, and all something like that. Okay. Anyways, what is quantum SDK? I'll just try to quickly wrap up this. At least this vocabulary might help you to go back and search something. Okay. Most of the things are open source. Okay. You can directly, you need not create any account also. You can just log in and do your own program. Okay. And they help us with different kinds of environment. It supports you to understand and learn from that. Okay. Learning by doing. Okay, that can happen with this different kinds of SDKs that are available. I would like to just end up with this. Quantum SDK is a programming language is different to use. APIs is different to use. And user interfaces is different to use. Simulators is different to use. Okay, we can only bundle SDK. Okay, just like your MATLAB. You can do it enter read data visualization actually. Similarly, all the other software that what you use, they are all SDKs. Okay. Similarly, quantum SDKs I will end here and this one. I'll end up with here. Okay. This is IBM Quantum. As I was saying, ప్రతిదానికి ఇదే మేము యూజ్ చేస్తాం చూడండి. Actually, we shouldn't use that, but as of now, they doesn't have different things. Okay, they are calling the same. IBM uses a tool gani, language gani, ఏదైనా కానీ generally called with Quantum. IBM Quantum. And similarly, Amazon Bracket. Okay, this is also high-level computing person generally uses Amazon Brackets, but it is a paid statement calculator. Okay, and similarly, the first one, IBM Quantum, as I was saying, it is mostly geared towards educational use and it is freely available for everyone. And similarly, the Intel Quantum Simulator, which is it is also a free and open source platform. And similarly, the Xanadu Penny Lane, okay, and Google Cell and Quirk. This Quirk, I suggest everybody to go back and check with this Quirk. Okay, Quirk is a open source platform, just like MATLAB ki konni open source software elaga unnayo. IBM Qiskit ki sambandhinchina oka open source Quirk. Okay, Quirk is very user friendly. మీకు అసలు ఎప్పటికీ ఏమి తెలియకపోయినా కానీ క్వాంటమ్ ప్రోగ్రామ్ స్టార్ట్ చేయాలి అని అంటే you can directly see this, the last one welcome to Quirk. You will have example circuits there directly listed there. Okay, that list you can choose one and try to handle that particular circuit and try to see how the program has been written for that. From that you can learn and implement for another circuit. This can be done. Okay, therefore Quirk is an open source software which can be used. Qiskit is also free, but you need to log in with your own user credentials. That means you need to register first and then you can use it. Okay, but however Quirk doesn't have that kind of any kind of ఎక్కువ మన మీద కండిషన్స్ చేయలేదు. You can openly use any. Okay, and you require for all these kind of SDKs, you doesn't require a quantum computer. Okay, you can have your own classical computer just like what you are using at PC. Minimum requirements. You can use this, and they are speed enough that you can execute those programs within seconds. Okay, you doesn't require any quantum computer. Okay, everyone please try to have a habit of writing your own program. Try to concentrate on writing your algorithms and how to approach towards that particular problem. Okay, nowadays design thinking is a most important subject. Okay, handling the problems, how to approach towards the solution of that particular problem. That is more important rather than communicating through a language like a developer. Okay, therefore I just try to end this talk here. And if you require more knowledge on Qiskit, I might be helpful for you. Okay, I can actually guide you through writing different programs, basic programs on Qiskit. Okay, I had undergone training on writing some programming related to Qiskit. I have tried this, but not the other software. Okay, there are also some kind of softwares where just like your EDA playground, you might have heard about EDA playground. You very long the different users ఉంటారు కదా, సినాప్సిస్ టూల్స్, వెండర్ గ్రాఫిక్స్ టూల్స్ అవన్నీ అలాంటివి మీకు కావాలి అంటే మీకు కాలేజ్లోనే చేయాలి. ఓకే, కానీ అదే మీరు ఓన్ సిస్టమ్స్ లో చేయాలి అంటే ఈడిఏ ప్లేగ్రౌండ్ అని ఒక సాఫ్ట్వేర్ వెబ్సైట్, దాంట్లో మీరు ఏం చేయగలరు, ఏ వెరీలో కోడ్ అయినా రాసి ఏ పర్టికులర్ టూల్ అయినా యూజ్ చేసేటట్టు చేయొచ్చు. దట్ టేక్స్ దట్ పర్టికులర్ కోడ్ అండ్ ట్రై టు go there and show us what is the output of that particular program in different simulators. Okay, you can see that mentor thesis చెప్పింది synopsis ఒప్పుకోదు, synopsis చెప్పింది ఇంకొక particular tool. That is not. Okay. Similarly, there are some kind of simulators, a bundled simulator which might also help you in order to compare your quantum program also. Okay, that is available. You can Google it and you can just check it out. Okay. Thank you for giving me this opportunity.
Thank you, sir, for your insightful and thought-provoking address. May I now request Dr. Srinivas Basu, sir, IQAC Dean, and Shravanti Madam, Assistant Professor, to felicitate our distinguished resource person, Dr. Aish Rasindra garu.
Be patient. It's more 2 minutes. Strictly following the time now. We have punctuality. The brand badge itself is called punctuality. Like you will maintain. Thank you, sir. Thank you for your wonderful information. During this schedule, I attended the orientation session. My speech is completed there. Then again, I joined here, the registration, and followed by the registration. So anyway, I promised for you people now. It's energy drink. Today the shop is closed. Tomorrow morning, today afternoon I can provide. Definitely. Sure. Afternoon, afternoon I will try. Take care of drinks, etc. These energy drinks. Coming to the session, I'm very thankful to the sir, Siddhartha sir. By looking science very simplicity, do you know what the president of the Aicte Vani society, sir? Imagine about it. We don't have Aicte Vani society. So we need to establish, definitely I will invite as a sir as a chief guest to the in our college, in our department. We will start definitely as a robotic automation or maybe signal process or 1 or 2 societies will start. It's actively, it's international level. It's not like simply it's a state or local level. It's an international level. It's not a national level. It's international. So like that we will plan definitely. So we will take the help from this sir also. We will start here and thank for this simulation, quantum simulation in terms of the tools for delivering the session. It's a wonderful session. Coming to this felicitation, madam, please with the token of appreciation.
Media